if we're asked to find the slope between 2 points, then all we're going to do is, what I do anyways, is I label these x1, y1, x2, y2. And the only reason I do that is so that I keep track of the fact that the slope, the change in y over the change in x, is equal to y2 minus y1, x2 minus x1, or equivalently y1 minus y2 over x1 minus x2. So the order doesn't matter, but what does matter is that if you're using the x1 first, then make sure you use the y1 first. And the same thing as if you use the y2 first, make sure you use the x2 first. So to find the slope between these 2 points, then I'm going to have this equal to 3 minus 5 over 2 minus a minus 1. So in the numerator, I will get just 2. In the denominator, I'll get a positive 3. What we talked about yesterday was that because this is positive, this is increasing. And it's increasing on its entire domain, which is from negative infinity to infinity. Because these are lines, there's no restrictions. So what we're going to be doing today is we are going to be talking about lines and graphing lines. And that's all we're going to do is lines and graphing lines. Now, if I'm asked to solve for x and then solve for y for this, then if I'm solving for x, then what I'm going to do is I'm going to bring that y to the other side, so 6 minus 3y. I divide everything by 2, and I get x is equal to 3 minus 3 over 2y. More often than not, we don't use that unless, of course, we are graphing by finding the x and y intercepts. And if you were graphing by finding the x and y intercepts, this is perfectly legitimate to do. Or if you were finding inverses, this is also what you would do. Normally, we actually solve for y. So I'm going to solve for y, so I get 3y is equal to 6 minus 2x. And then y is equal to 3 minus 2/3 x. Typically, however, unless you're in a stats class, we will typically write it with the slope and the x part first. But it's not wrong to leave it right here. It's totally fine to leave it right there. So what we're doing today, if there's no questions, I'll stop and ask if there's questions. If there's no questions, we're going to be doing linear functions, and we're going to be graphing linear functions. So before I move on, is there any questions about the warm-up here? Since there are no questions, we're going to go back to what we're doing today, which is we're going to be doing linear functions. Now, what we see is this. We should be familiar with this from our previous math courses, where y equals mx plus b. This is called the slope intercept because I have the slope and the intercept. The y part of the intercept is given. And it's easy to go from the slope-intercept equation into function notation. Function notation is, if we know it's a function, we replace y with f of x. Talked a little bit about the slope, and we'll talk about it again for a minute. What the slope is how I move from one point to another. It is my y value, and it's going to be divided by my x value. If I'm going up and right, it is positive. If I'm going left and down, it's still positive. But if I'm going left and then up, that's a negative slope. So left is negative or down is negative. So it depends on how you look at it. Going right is always positive. Going up is always positive. So if you go left, then it's negative. And if you go down, it's negative. Double negatives make it positive. If you go left and up, then you end up with a negative slope. So here's how we define the slope. Now, before, what we define the slope of the secant line, if you remember, the slope of the secant line was the change in the y values divided by the change in the x values. So this is what we seen when we were asked to find the average rate of change. It was the slope of the secant line. We talked a little bit yesterday about the increasing, decreasing, and it's increasing and decreasing on its entire domain. Because it's a line, it is always increasing if the slope is positive. If the slope is negative, we are always decreasing. If the slope is 0, we have a horizontal line, and we have just y equals some number, or f of x is equal to some number. It's a horizontal line. Again, the slope of the line is how you change. If you go in this direction, it's positive. If you go in this direction, it's positive. If you go in this direction, it's negative. And if you go in this direction, it's negative. So left and down are negative movements, and right and up are positive movements. The standard form of the line is, and you'll see it this way, is ax plus by is equal to c. We prefer it in slope-intercept form because it allows us to write it in function notation and allows us to figure out how to graph it quickly based on the y-intercept and the slope that tells us how to move from point to point. Sometimes we will have to use this intermediate form of a line to get to the slope-intercept. My preference is to use this, but in a modified form, which is y is equal to m x minus x1 plus y1. So that's the one I prefer to use for the point slope. It's a modified point slope. And with the point slope, you need to know the slope, and you need to know the point x1 comma y1. And you need to know the slope. So slope-intercept, or the point slope, is one of the intermediate steps that we will use to find it in function notation. Again, we see the slope-intercept form. Here are the different ways to represent a line. So I'm going to stop here, give you an opportunity to write these down. Now, again, my preference on the point slope is y is equal to m x minus x1 plus y1. So I'm just going to give you a couple of minutes to look at that and then also to ask any kind of questions. We finally want to find the equation of a line with a slope of a negative 1/2 containing that point. Then we want to write it in slope-intercept form. So I'm going to use this modified version right here. I'm going to use y is equal to m because I have an m value, x minus x1 plus y1, and then that'll allow me to put it right into this form. Now, some of you may be familiar with using this form right out of the gate and then putting in your m and your x and your y here and solving for b. I don't have a problem with you all doing that. It just means that you're going to have to take an extra step of putting it back into this form. If you use this one, it's already almost ready to rock and roll. It's just a little bit of simplification. So, with that said, I'm going to use that modified form. So y is equal to negative 1/2. And then it's going to be x minus 5 and then plus 3. And it's almost ready to go in the form that I need. And again, the form that I need is this, y is equal to mx plus b. So all I need to do is distribute the negative 1/2 through and then combine up whatever constants I have. So I've got y is equal to negative 1/2 x plus 5 over 2 plus 3. And then y is equal to negative 1/2 x. So I'm going to go over here and I'm going to add 5 over 2 plus 3. These need to have the same common denominator. Now remember, 3 I can write as 3 over 1. So this I don't have to do anything, multiply by 1 if I want. But over here I do need to multiply by 2 over 2 so I can have the same common denominator. When I'm done, what I'm going to have is I'm going to have 11 in the numerator over 2. So I can write this as 11 over 2, or I can write it as a decimal equivalent, or I can write it as a mixed number. In web work, you will need to use either the fractional form or the decimal equivalent. Do not write this as a mixed number. Now, if you were asked to graph this, it would make more sense to write this as a mixed number or as the decimal equivalent. 11 halves, more than 5, less than 6. So when you are entering this into web work, you will probably enter negative 1/2 x plus 11 halves is 5.5. That is probably the preferred way to put it into web work. That off the top of my head, that would be the preferred method. Although putting it in like this is totally fine. What you're not going to put in there is 5.5. Does that make sense? Any questions? Okay, cool. If there's no questions, and I'll leave this up for you all to look at, I want you to go ahead and do B and C, please. So let's take a look at that. The question is, The subtraction, does it matter which way we subtract? It doesn't matter which way you subtract. When they're asking you for the slope-intercept form, that is of this form. So rather than having the 0 to the other side, and it wouldn't matter which points you have, and it wouldn't have mattered this way either. So if I found the slope of this by doing the -5 minus 0 over the -4 minus 4, then what you're going to get is -5 in the numerator and -8 in the denominator, which still should give you 5 over 8. So it doesn't matter which way we subtract in terms of the slope. So if I'm looking at my slope subtraction, whether I did the first ordered pair minus the second or the second ordered pair minus the first, I'm still going to get 5 over 8 if I made sure that my signs were correct everywhere. And then down here, it doesn't matter which way you subtract. I mean, I could have said y plus 0 or minus 0 is equal to this. I prefer this modified because, like I said, it just gets me right to here fairly quickly. Okay, so what do you all have for C? I want a horizontal line that contains a point 1, -3. For a horizontal line, it is y equals, and so if y equals, I have to go through this point. Y must equal -3. So horizontal line, y must equal -3. Now if I wanted a vertical line, so instead of horizontal it said vertical, then my answer to the vertical line would be x is equal to 1 because I'd have to go through that point. So horizontal is just y is equal to the y part. Vertical is just the x is equal to the x part. Let's go ahead and move on if there's no questions. Yes, so the question is for this is when I'm looking for horizontal lines, I can use these right here, where C, doesn't matter what the point is, C is the point that is the x or the y value. In this case, if I have the ordered pair, say 3, C, whatever that C is what the horizontal line would be. In this case, if I had C, 7, then my answer would be whatever C is, x is equal to whatever C is. So yes, we're just pretty much putting in the x or the y part for the C. We don't really care about the intercept in and of itself unless it's asking me, but we're really just saying, hey, that x or the y value is what we write for y equals or x equals for the horizontal and vertical lines. And we're going to talk a little bit about this, so let me just talk a moment. Parallel lines, if they're parallel lines and they're not the same line, they have the same slope, different intercepts. And then if I have two slopes and when I multiply them together, it equals -1. So that's telling me my lines are perpendicular if they're negative reciprocal slopes. The lines are parallel if they have the same slope but different intercepts. Okay, so there's going to be a couple of questions like that down here. So what about this one? I want an equation of a line with the point 6, -2 with an undefined slope. Now think about how we define slope. Slope is the change in y. So slope is the change in y over the change in x. So think about how we determine the change in y and the change in x. Which one would this be for an equation of a line with a point that goes through the point 6, -2 with an undefined slope? So because of the way that we define the change in y over the change in x, we have an undefined slope when we have a vertical line. Because that way the x is not changing. So if the x is not changing, the delta x is 0. And if I'm dividing by 0, that's undefined. So one way of saying I want a vertical line is saying I want a slope with a vertical line is saying I want an undefined slope line. These should be the same thing. So x is just equal to 6 on that. So any questions on that one? So as we take a look at this one and we want to write the equation of the line in standard form. Standard form is the form of ax plus by is equal to c. So we want this in standard form. So I want the equation of the line that is described by these 2 points. And go ahead and do that. I'll give you a couple of minutes. Okay, so let's take a look at this one. Now with this one, I didn't have to do the slope equation to find my delta y delta x because it's already graphed for me. And all I'm going to do is I'm just going to count the change in x and the change in y. The change in y, I went from from 2 to 5, so I've gone 3, 1, 2, and 3. And then in the x direction, I went 4, so I went from -1 to 0 to 1 to 2 to 3. So there's my slope. I'm going to use this ordered pair, and so it's going to be y is equal to, and I'm going to use the point slope initially. So y is equal to 3/4, and then x minus a minus, plus 2. So this is where we are so far. So y is equal to 3/4 x plus 1 plus 2. Now, in the standard form, typically in the standard form, if we can avoid fractions here, we try to avoid fractions on the a and b and c, if we can avoid it. So if we're asked to try to avoid the fractions in a, b, and c, then what I'm going to do is I'm going to multiply everything by 4, so I don't have to worry about any fractions, because typically in standard form, a, b, and c are non-fractions. They're typically integer numbers. So I'm going to come over here and I'm going to multiply this by 4. I'm going to multiply this by 4. I'm going to multiply this by 4. And again, the only reason I'm doing this is because typically in standard form, we don't have fractions. So I get 4y is equal to 3, x plus 1 plus 8. So I end up with, over here, I'm going to end up with 4y is equal to 3x plus 3 plus 8. And I'll answer that question in a minute, Alana, why we don't typically do the decimals. So then what I do is I need to bring everything over to the x, all the x's and y's to one side and all the constants to the other. So negative 3x plus 4y is equal to 11. Now, we typically, standard form usually has a positive leading coefficient, but it is not incorrect to leave it like this. I could leave it totally like this. Typically, though, we write this as 3x minus 4y is equal to a negative 11, because standard form typically likes to have a positive x. This is okay. Typically, this is going to be the positive coefficient on x. That means everything else, all the other signs need to change. And again, when we are in standard form, the coefficient on x and y, and typically the constant, are all going to be integer numbers, so there shouldn't be any decimals in it or fractions. So this is what it would look like in standard form. Is I would have a positive x, because we usually start with x being positive, and then we'll make sure that there's no fractions or decimals anywhere there. When you see this form, it's because we'll be doing a system of equations. So when you see this form, typically we'll use this when we're trying to solve, which will be in 2.3, when we solve where the two lines cross. So this is a form that you would see in that section. This is a form that is going to be difficult to graph because you have to do a little bit of algebraic manipulation, unlike when it's in this form. When it's in this form, it's almost pretty easy to get to the graphing. This one's a little bit more difficult, but not impossible. Okay, so let's take a look at the next two. So we're going to skip F. It's actually a really, really good algebra question, but it also needs to know the distance formula, and that's something that's not being tested in this section. So we're going to skip F for now. We're going to come back to it. It's a pretty cool problem if you love algebra. If you don't love algebra, it's not really a cool problem. So we're going to leave it for right now. We'll come back to it another time. But let's go down here and determine whether or not these lines are parallel, perpendicular, or neither. So if I was trying to determine whether or not these are parallel, perpendicular, or neither, then I would either put this in standard form and do a comparison on the coefficients, or I would write it in slope-intercept form. I'm going to go ahead and write this in standard form because this top equation is already in standard form, and it won't take much to put this into standard form. I could solve for y here. Maybe I'll do that. So yeah, let's do that. So I'm going to solve for y on this one, and I've got 3y is equal to negative x plus 12. Then I'm going to divide by 3, so I get y is equal to negative 1/3 x plus 12 over 3. So that would give that 4. So that's that line. This line, I have to make sure it's also in the same form. So I just divide everything by a negative. So y is equal to negative 8x plus 1. And this is, I know the answer to this is neither, because if they're parallel lines, then the slope of one is equal to the slope of the other with the different intercepts. So the b sub 1 does not equal b sub 2. So in other words, the equations have different intercepts, but they have the same slope. If they had the same intercept, they're the same line, so they're not parallel. The other one is perpendicular. And the way that these work is the slope of one is the negative reciprocal of the other. So they are negative reciprocals. So if I multiply these two together, so m1 multiplied by m2, this should equal negative 1. Now the answer to this one is neither. But if I was asked to determine whether or not these are parallel or perpendicular, I would have something that looks like this. So I have 3y, I'll do 2x plus 3y is equal to 7. And then I have 3x plus 2y is equal to 12. Now, for these to be parallel, my x coefficients and my y coefficients must be the exact same thing. So looking at these are not parallel. So that's because the slopes are not the exact same thing. My x coefficients don't match, my y coefficients don't match. So I know that they're not parallel. So then I would ask myself, are these perpendicular? And if for them to be perpendicular, then the coefficient on the x must be on 1 must be the coefficient on the y, so that seems to match. So 2 on the x and 2 on the y. And then when we have 3 on the y and I have 3 on the x on the other one, those seem to match up. However, not only does the coefficient on the x must be the coefficient on the y, and the coefficient on the y must be the coefficient on x, they have to be opposite signs. So these are not perpendicular either. So if I looked at it in standard form, these are both in standard form, I can tell you by inspection that they're not parallel because the coefficients on the x don't match and the coefficients on the y's don't match. And they're not perpendicular because the coefficients on the x should be the coefficients on the y. The coefficients on the y should be the coefficient on the x. And one set has to have opposite signs. So what I mean by that, these are not perpendicular, but 2x plus 3y is equal to 7. 3x minus 2y is equal to 7. These are perpendicular. And that's because the coefficient on this x matches that coefficient on that y, but with opposite signs. The coefficient on that y equals a coefficient on that x. As long as one of those have changed signs, we are perpendicular. So these are perpendicular. And you could check that by solving for y and discovering that their slopes will be opposite, but they're going to be reciprocals of each other. The slope of this one here, the slope of this, is going to be negative 3 over 2, and the slope of this is going to be a positive 2 over, sorry, it's going to be this one, it's going to be the other way around. This one is going to be 2 divided by 3, 2 divided by 3, and then this one is going to be the 3 divided by 2. And you can tell by multiplying these two, so negative 2/3 multiplied by 3/2, it equals negative 1. So that's how you tell whether or not they're parallel or perpendicular. There's some questions on the homework about it, so I just thought I'd cover that now. So parallel and perpendicular. All right, I'm going to stop first though before I move on. Is there any questions on parallel and perpendicular? I'm just gonna do one more example. We're gonna flog this a little bit just to make sure that you all have all the things that you need for your homework. So suppose you have the line y is equal to 3/4 x plus 5, and you have this point 1, 2. If you want a line that is parallel and through that point, then you would set it up like this. Y is equal to 3/4 x minus 1 plus 2. And you would just use the slope in the point slope form, the modified point slope form. The slope has to be the same. And then you're just ensuring that it goes through that point. Now, if you wanted a line that is perpendicular, and that's a symbol for perpendicular, as soon as that shows up, that goes through the same point, then you would write y is equal to negative 4/3 x minus 1 plus 2. And this slope here has to be the negative reciprocal of that slope. So there you go. Parallel and perpendicular lines. It's kind of a refresher. All right, so if we are asked to find, and we'll spend some more time on these tomorrow when we do 2.3, an electrician charges $140 to make a house call and $85 per hour in labor. Sometimes I think I should have gone into the trades. It probably would have made way more money than I am doing now. Or I could have stayed an engineer, but whatever. I like my job. But electrician is going to charge you $140 just to come out to your house. And then he's going to charge you $85 in labor. This is not asking an electrician to come out and give you a bid on something. This is saying, I need you to come out and fix something because, my breaker box isn't working or something. So electrician's going to charge you $140 to come out and $85 in labor, which actually is pretty cheap, by the way. So to make this into a linear function, c of x is going to be, this is my intercept. That 140 is my intercept. So if he comes out or she comes out and says, okay, there's nothing wrong with it, they're still going to charge me $140, whether they spent a moment or not. The thing that's changing is that, and it's per hour. So that tells me that must be my slope. So it is $85 per hour, and then with $140 regardless of what they do to my stuff. So let's take a look at B. I want you to read through it and see if you all can do B, and then I'll give you a couple of moments to try to go through it, and then we will answer that one too. So as you read through this, what we have is the independent is the yield, the independent is the number of beanstalks you plant, and the yield, or the dependent, is the y. So we have the first two ordered pairs, and then what we want to do is we want to find the slope. So I'm going to do 30 minus 28 over 30 minus 34. So in the numerator, I'm going to get a positive 2. In the denominator, I'm going to get a negative 4, which means I have negative half is my slope. Now, what that means is that I must have a small enough lot that the more beans I plant, the less likely they're going to be successful. So if I plant a bunch of beans stalks, then my yield isn't going to be as much because each beanstalk is not going to have the opportunity to get all the nutrition it needs to be able to grow big enough to get enough beans. So we have this slope of negative 1/2, and then I'm going to just choose one of the two. It doesn't matter which one you choose, ordered pairs. So then I have y is equal to negative 1/2. N is the variable we want instead of x, so make sure you pay attention to that if it's on the homework. And then minus 30, and then plus 30. So y is equal to negative 1/2 n plus 30 divided by 2 plus 30. So my answer is negative 1/2 n plus 45. Is there any questions on that? How I got any of those pieces or anything like that? I'm hoping that these sections, I hope, don't stress you out too much. I'm hoping that these are something you have seen before. Lines are something you're familiar with. And if you're not, that's okay too. It's totally fine to say, well, I've never seen this before. Totally fine. Is there any questions at all on this? Because I want to talk a little bit about the intercepts, and then we'll call it a day.